to another video tutorial. In this lesson, we are going to discuss about operations on rational algebraic expression. Once again, I am your teacher, Ma'am Coren. So this video will be divided into three kasi masyadong hahaba tayo kung isa lang. So for the first part, we'll have multiplying and dividing the rational expressions. Then for the second part, we have adding and subtracting rational expression with like denominators. And then for the third part, we're going to add and subtract rational expression with different denominators. So first, let us have multiplying rational algebraic expressions. So in multiplying rational expression, we have P over Q times R over S, which is actually equal to P times R over Q times S, meaning we are simply multiplying the numerator by the numerator and multiply the denominator by the denominator. Be reminded that P, Q, R, and S are polynomials in one variable, and Q must not be equal to 0 as well as R and S. For us to have or do not have an undefined rational expression. So when we multiply fractions, we can simplify before or after multiplying by dividing out the common factor to both the numerator and the denominator. So for our first example, we have 8 over 14 times 7 over 12. So what are we going to do? We are going to multiply first and then eliminate the common factor. So 8 times 7, yes, that is 56. How about 14 times 12? That is equivalent to 168. And then, after that, we are going to factor the numerator and denominator for us to simplify the common terms. So, 56 can be written as what? What is the prime factorization of 56? Yes, it's 2 times 2 times 2 times 7 over 14 and 12, so we have 168. So we have 2 times 7 for 14, and then for 12, we have 2 times 2 times 3. Since it is already written in prime factorization, we can now eliminate the common factors. So we have 2, 2, 2, and 7. So our final answer is it 3? No, that is 1/3. Kasi whenever there is no factor left in the numerator, remember that there is always 1 in our numerator. And then the other way around, we can eliminate first the factor, then afterwards we can multiply. So what is the prime factorization of 8? So that is 2 times 2 times 2. And for 14, we have 2 times 7. For 7, so it is already a prime number. For 12, it's 4 times 3, wherein 4 is equal to 2 times 2. And then we have 3. So we can cancel out the common factors. So we have 2. Also have 7. Cancel 2. So therefore, we have 1/3. So as you would notice, we come up with the same answer, but on the first one, we multiply it first before eliminating the common factor, while the other way around, we eliminate the common factor before we can multiply. As you would notice, it is easier for us to have the elimination of common factor first before we multiply. So that is what we are going to do when we multiply and divide rational expression. We are going to eliminate the common factor first before we multiply them. So what are the procedures in multiplying rational expression? First, write its numerator and denominator in factored form. And then if you have already written the factored form, we are going to divide out any numerator factor with any matching denominator factor. So yun yung ginawa natin kanina. And then for the third one, we multiply the numerators and then also the denominators. And kung possible pa, we are going to simplify. So let us have the first example. So multiply and simplify each. Yung a to the fifth power, we may write that as a times a times a times a. Pero in simplified form, di ba, can you still remember the quotient rule? So when we talk about the quotient rule, we simply subtract the exponent. Or for visualization, again, you may write a times a times a times a times a. And then for 10, the factors of 10, it's 5 times 2. 5 is already a prime number, so we write 5. Then for a cube, so we multiply a thrice by itself. And then for step 2, we are going to cancel out the common factors. So we have 5 here, cancel ang 5. For a, we can cancel a, also this a, and then a. So we are left with a squared, since we have remaining 2 a's. And then on our denominator, we have 2. So, sabi ko kanina, you can use the quotient rule by simply subtracting 5 minus 3, which is 2. And 5 is higher than 3, so we'll place a square on our numerator. For our second example, we have 30b squared over 6c times 4c squared over 15b to the 4th. Again, we may write the prime factorization. So 30 can be written as, yes, it's 2 times 3, which is 6, times 5, and that will give us 30. While b squared, it's b times b. For 6c, we have 2 times 3, 6, times c, we have 6c. And then we have, for the other factor, we have 4c squared. So 4 can be written as 2 times 2. C squared, it's c times c. For 15b to the 4th, so we may write it as 3 times 5 times b times b times b times b. Or sabi ko nga kanina, pwedeng yung quotient rule. You simply subtract the exponent. So we can cancel 2. Cancelled out din ang 3. We also have 5 here. Yes. C, correct. And then B. May isa pang B. So, sa numerator natin, may natira tayong dalawang 2. So, we simply multiply all the remaining factors in the numerator as well as with our denominator. So, 2 times 2, it's 4. Times C, it's 4C. Over 3 times, yes, it's 3b squared. There's no other common factor, so this is our final answer. How about this one? We have 3d over 3f minus 12 times 4f minus 16 over 12d squared. So again, we get the factors of the numerators and denominators. 3d can be written as 3 times d. How about 3f minus 12? So since 3f and 12 are not perfect number, so we can have the common monomial factor, which is, correct, common sa kanila ang 3. So the remaining or the other factor is f minus 4. Times, ang 4f minus 16, yes, ang common factor nila ay 4. And then, you're left with f minus 4 as the other factor. Dinidivide lang ulit. Yung kagaya nung lesson natin about factoring. For 12d squared, can be written as 4 times 3 para we can cancel 4. And then we have d squared can be written as dd or d times d. So now we can cancel 3. F minus 4, yes. And then pa? Yes, we have 4. Saka yung isang d. And walang natira ulit tayo sa numerator. So ang ilalagay natin ay, correct, yan ay 1. And then 3 times d, it's 3d. 3d is different from 1 over 3d. So whenever there is no other factor left in our numerator, we simply write 1. So that is multiplying rational expression. This time, let us have dividing rational expressions. So whenever we have the division of rational expression, we have P over Q divided by R over S. We have P over Q times S over R is equal to PS over QR. And again, QR and S must not be equal to 0. So that will be our formula or pattern whenever we divide rational expressions. So what is the actual procedure? First one, as you would notice, we get the reciprocal of the divisor. And then making our division statement into multiplication statement. Then for the second one, similar to multiplication, we factor the numerator and the denominator. And then we can cancel the common factor between the numerator and denominator. Then afterwards, multiply the numerator and denominator. Tapos kung pwede pang simplify, you may simplify it. So for first example, let us divide this one. 7 over 6x divided by 7 over 12x. So for the first step, we are going to have this division symbol to multiplication sign. Then we get the reciprocal of 7 over 12x. For the reciprocal, simply have the numerator be placed on the denominator and the term on the denominator be placed on the numerator. So pagbabalik ta rin lang yon. So we have 12x over 7. Yan. So we can cancel now 7, x, 12. Yes, this is actually 6 times 2. So pwede natin i-cancel dun si 6. Ang matitira na lang ay 2. So we are left with 2. For our denominator, yes, wala na common factor na natira. You may write 1, but since any number divided by 1, still the number itself. So still it's 2. For our second example, we have a to the fifth over 4 divided by 4a squared. So notice that 4a squared do not have a denominator. But actually, it has a denominator which is, yes, there is always a denominator of 1 kung wala man lang tayong nakikitang denominator sa ating term. So we may, again, express it into multiplication statement. So we'll have the multiplication sign here, then get the reciprocal. So it's 1 over 4a squared. Similar to what we did a while ago, you can have the a times a times a times a, basta lamang a at saka dalawang a, or we can have the quotient. So we have 5 minus 2, it's 3. So this will become to the third power times 1, so that is a cubed over 16. So this is already our final answer since we have 4 times 4, which is 16. Then for example number 3, it might be sound or look like difficult, but it's actually easy. Again, we copy the first fraction or dividend, then change it to multiplication sign. The divisor, the denominator now will be on the numerator since we are getting the reciprocal over x minus 4. Next step is to factor out. So 16 minus x squared is actually the difference of two squares. So that is 4 minus x times 4 plus x over, since this is x squared plus 2x, it is a common factor of x times x plus 2. For the other fraction, so it has a factors of x plus 2 times x minus 2. As you would notice, it is also written in the difference of two squares. X minus 4 do not have any other factors, so simply write it. So what are the terms or factors that can be cancelled? Yes, we have x plus 2 and x plus 2. Yun lang. Yan. As you would notice, we have here 4 minus x and the other one, it's x minus 4. So technically, we cannot cancel that one. But we can factor this one as negative times 4 minus x. So we can now cancel 4 minus x and 4 minus x. So for our final answer, i-switch lang natin itong dalawa, but we are not going to change the sign. So we have x plus 4 times x minus 2. For our denominator, we are left with x. This, as you would notice, we factor out negative 1 a while ago. So we cannot simply eliminate the negative sign. So we also write negative on our final answer. You may replace it here on the denominator beside x, or technically, we usually write the negative sign at the middle. So that is dividing rational expressions. So that is all for multiplication and division of rational expression. I hope you learned something. And for our next video, we'll be having addition and subtraction of rational expression with like denominators. Once again, this is Teacher Coren, your teacher for today. Have a great day, everyone.